Hello, welcome to Topper Machine. I'm Josh Topper, and today's job is another interesting one. This is a throw arm out of a baler. Then there's actually a shaft that runs off of this, similar to the crankshaft I did for the steam locomotive or steam engine, but it just runs on this, and the bearing is chewed up. So we need to replace this shaft. So I'm told this is out of a 𝐃𝐨𝐧'𝐭 or a New Holland baler. So 𝐃𝐨𝐧'𝐭 is one company now, and here is the shaft, how wore that is. And I already got all my measurements off of it, what I need. And we're gonna take the coaxial indicator, find center, machine this off, bore through this, and then we're gonna shrink a new pin into that. And then I'll probably do something on the backside. I'm not sure if this is cast iron, cast steel. We'll find out real soon when I start machining on it. So I got the coaxial indicator in here, and I just kind of centered it. So as you see, as I rotate it, my needle doesn't move much. I'll just use that to eyeball myself as close to center as I can get, and then we'll come down and find center. I'm not very far off. So personally, I don't care for this method because it's really hard to tell which way you're actually going. And it looks like I'm actually going the right way, but I'm going to stop it because it's really a lot easier to just rotate it by hand and figure out just which way you need to go. So I need to adjust this way and this way. I'm just going to come up a little bit more here, get a better bite on my part. And we are very close. So considering there's a little roughness on the surface of that shaft, I'm going to call that pretty good. Actually, I can just take a little bit there. That might get us there. Oh. I'm going to call that good enough. So we'll zero our readout. And instead of coming at it and milling off a little at a time all the way down there, I'm going to cut the whole thing off. There it is. In one shot with the slitting saw. Just make it a lot easier on me, a lot less machining overall, you know, multiple passes and everything. This will just take it in one shot, and then we'll finish it off with an end mill and then do the boring. Now before I start cutting here, I did get a full measurement from the top here to the bottom underneath, and that'll be what I set my height off of. So when I machine this all off and do everything, then we'll compensate with the pin when we put it in. Put a little anchor lube on our cutter here. Well, that cut off really nice. I'll just have to touch that up with an end mill, but that'll work, and then we'll do the bore. All right, so I'm just going to go ahead and mill some of this off. All right, next step here, we'll drill our pilot hole, and then we'll drill through with the 1 1/8" drill, and then I'll set up the boring head, which I was really hoping not to do. I was actually hoping to do this all with a reamer, and then compensate on the shaft that I have to put in it. All right, so I got my boring and facing head set up here. This is a boring and facing head. You can adjust it on the fly. Pretty nice little unit. I don't use it a lot, but this is what I have for a boring facing head for the Bridgeport. This is the only one I have. I've got a couple different styles that'll fit the Cincinnati and the horizontal boring mill, where I do most of that oddball boring stuff, or I do most of it in the lathe. But we're set up. I've got it close. We'll go ahead, touch it off, come out, open it up a bit, feed through, and then measure our bore, see where we're at, and see what we need to go to. Well, that made a very nice smooth bore. I only took 10 thousandths on my dial here. I'm going to move this over and get a quick measurement, see where we're at. We'll get it close to what I want, and then I'll take the bore gauge and figure out right where I'm at. All right, looks like I'm about 1/113 by the caliper. And basically we're just going to take another 10, verify what the reading is on the boring head, and then figure out where we need to go from there. So 10 is actually 20. So we're at 33. We were at 13, well, we're at 33. And I want to go to 85, so we need to take another 26 thousandths, but I'm only going to take another 20, which will be, or 52 thousandths, which is 26 thousandths on the unit, and I'm taking 20, so we're going to take 40 out of the bore. We'll measure it again, see where we're at, and then make the determination. All right, so by the caliper, I was seeing 1.174, 175, and like I said, never trust your caliper. And I bring it in here, the bore gauge in here, and I am seeing, so there is my 0, and I am plus 3. So I set it at 1.175, I am 1.178. So I don't have far to go to hit my 1.185. I actually only have 7 thousandths to go, so let's see if we can hit that with one shot here. All right, so here's another 7 thousandths. Let's see how we do. All right, let's just see what we did here. Well, I am 5 under. So that's 1180. I can live with that. I can just make the pin to fit. The pin is actually going to be oversized, so it's a shrink fit. But this boring and facing head, it's a great concept, but it's not the most accurate thing. I think this is a knockoff of a 𝐷 I'm not sure. I've never seen a tag. I didn't have a tag with it, but it sure looks like a 𝐷. It's a great concept, but just I don't trust it, so I tend not to use it a lot. But this will work fine. We're in good shape. We'll make the pin next. All right, so this is just a chunk of material, 1.25 inches that I had laying around. It's got a hole in the end here. We're just going to machine that off so we can get started. So I'm going to go ahead and turn this end down to 1.183, 937 thousandths deep, so 15/16, which is what our plate is there. I'll set my readout here at 0. And I'm just going to touch it, make a little mark. And I'm going to take my first cut. And we're gonna go with a 1.183. That's 3/1000ths oversize of our bore, so it'll just drop. It'll be a nice snug fit, and it'll lock right into that plate. And just use the caliper to see how close we are. I'm going to take another 30 and then we'll switch to the micrometer, but I'm going to slow my feed rate down. I want this thing as close as possible and as smooth as possible so it goes together good. So here's another 30. And now this is the same micrometer I used to set my bore gauge. So that's a little trick you can remember for measuring the part you're making to fit it. Just use the same micrometer you set your bore gauge with. That way you know your readings are going to be where they need to be. And I am at 91 right now, 1191. So I got 0.008 to go. I'm going to take 8. Now let's see how I did. $1183, right on. Let's check it at the other end too. We won't have to polish this. Yeah, looks good. 1183, perfect. I'm going to put a little bit of a chamfer on there with probably just with the file. I'll knock that burr right there at my corner. Perfect. And I'll just slide it out and I'll cut it off the length, and then we'll flip it around and I'll put it in the collet chuck. Grab on here to finish the work on the other end, because this is the important end. We get this right and that'll lock right into that plate. I'm just going to use one of my sacrificial calipers to scribe a line there where we're going to cut it off, which is over length. All right, so here's another great tool to have, is this collet chuck. I've got a 5C collet chuck, and I've got this 2J. And this thing has been an absolute lifesaver in the fact that it goes up to, is it 1 3/8? So it's a nice size all around for just about any shop. Actually, before I clamp this down, let's measure the overall length, find out where I'm at, and just going to measure on the outer edge, 537, and we got to go to 430, so I've got 107 to take off. I'm going to shift into a lower gear here so I can get a good bite on it. There we go. So we'll take 137 off that end, and then we'll start turning the features. All right, so now I got to go 1.406, and let's just verify that it's going to work, and it leaves me just a little shoulder. That's about perfect. Zero there, and we'll take our first pass. We're going to 1.181, which is metric. I'm going to take 50 thou on this first pass. .203 by the caliper. And let's just see what the micrometer says. .202. Let's check it back here to make sure there's no taper. .202. So we've got 20 to go, 21 to go. We'll take 20. We'll take 18 at a slower feed rate, and actually we'll just go a little bit and see what it looks like. As we are just getting into where the snap ring is, so this is a good place to test it. 1.182, perfect. We can polish the rest out. Not a big deal. We want that bearing to fit nice and snug. Okay, so since I got my distance calculated from this lip, we're just going to touch off with my snap ring, my grooving tool here. That'll set my depth. And then we'll come back to what we need. So there's my depth. And then over. That's where the snap ring groove goes. And we'll just touch it off. We only need to go in 55 thousandths. And there's the snap ring groove. Knock my burrs off and we're good to go. All right, so there's our pin all done. There's our bore all done. Now I'll just go and I'll make up some dry ice. We'll get this in the dry ice to get it to shrink. And I think we'll heat this up a little bit and just slip them together. And once it cools, that will lock in there so tight. The it's not going to come out. We won't have to do anything else. That 3/1000 fit should lock this thing up perfectly. All right, so I know I've talked about this in the past, is getting supplies in this region is very difficult. Liquid nitrogen would be best for this, but again, that's something very difficult to get. Dry ice is available, but I have to drive at least an hour one way to get it. So I opted for option 3 of making my own. This is a CO2 tank with a dip tube and a dry ice making unit. That's basically a nozzle with a bag, and you just turn it on and make dry ice. Now there, my tank is getting pretty low, but I've got enough dry ice just for this job. I've done about 5 jobs off of this, making a lot more dry ice than I just made right now. All right, before we even get started, I want to measure this with the caliper and just see what the caliper says. 82. We know it's 80, but I'm going to start heating it up. And that's the nice thing about having cheap calipers around, is you don't have to worry about wrecking them. By the caliper, that opened up a few thou. And the reason I'm doing that is just to ensure that the pin goes in good. All right, here goes nothing. Shit. Well, as you saw, it went in part way and it stuck on me, and I ran it over to the press quick and I got it in. Got lucky there. These press fits are always fun. Shrink fits, that was 3/1000. That's not ever coming out of there. So I thought maybe tapping it with the hammer a couple times would have got me down there, but getting it to the press was the ticket, luckily. Well, we got it. It's done. This job is ready to go back to the customer, go back in the baler and back in the field. Definitely could have gone better, but I tell you what, after doing these press fits, I found that having a beer afterwards is definitely something you got to do. You just need a beer or a whiskey or a shot of pure straight alcohol. Depends on what you're into, but yeah, this one could have gone a lot worse, and it went pretty well, surprisingly, and we'll get this done, back to the customer. The reason we did this job, this assembly here is, I think he told me $2,300 from New Holland. So to do a repair like this that, maybe a couple $100 is definitely worthwhile to repair this versus buying a whole new one, because there's nothing wrong with the rest of it. So with that, I hope you enjoyed the video, and until next time, get out in your shop and get it done right the first time.